Well, welcome to a special edition of Les's Corner. We're with Matt Reisinger today of the Build Show. So we're doing this in collaboration with him and his show. So hi, Matt.
Hey, Les. Thanks for having me.
You bet. And we're actually coming from the Sashco lab where we have also with us on our team, Nathan Ferraro. He's on our product development team. So he's going to help us out today on our subject. And what we're talking about today is the supply chain impacts everybody's feeling. And we're going to really look at the impact of that on the sealant category and how contractors might navigate that through some technology swaps. So really appreciate you joining us today, Matt.
Definitely, Les. Looking forward to it. You know I love these nerdy topics.
That's right. We're going to nerd out today.
Les, it's safe to say that you and Nathan are a bit of an authority on making and selling sealants, given you both have a chemistry background. And Sashco has been around for, what, 85 years now as a leader in this category. For those of you in the audience, Sashco makes popular brands like Big Stretch, Lexel, and Through the Roof. And as most people in the building industry are aware, we're experiencing some crazy supply chain issues now. And I actually have a story from this morning on the job site. Before I get into these guys talking about the sealant category, I want to mention another category. This weekend, a buddy of mine texted me a photo of the shelves at Home Depot in the drywall aisle. And there was no drywall mud to be found anywhere at the Big Orange store. He said the only drywall that was available, mud that is, was Easy Sand 20 in a bag. Other than that, you could not find any anywhere. And he knew that I was in the drywall phase because I'd taken a picture of me in the job the other day with, like, 40 cartons of drywall mud behind me, and couldn't believe that they were totally sold out. So then I tell this story to my drywall guy this morning on the job, because I'm in the drywall phase right now in my house. And he goes, "Oh yeah, my drywall supplier called me last week and said, hey, we're running low on stock on everything. Do you guys need some mud for any of your jobs going?" And my drywall guy, savvy as Junior is, goes, "Well, yeah, I definitely need some. How much do you have in stock?" He said, "Well, we got 6 pallets left." I just said, "Oh, that's crazy. That's exactly how much I need, 6 pallets." So, I mean, this is crazy, boys. What can you guys tell us? What are you seeing at Sashco in terms of disruptions?
Well, yeah, Matt, we certainly are. I mean, upstream from that supply chain, from you, from the Big Orange, all the retailers, definitely from our standpoint, we have been struggling on raw materials all year long. And fortunately for us, we're mostly U.S. based on raw materials, but our purchasing team has worked solidly, I mean, daily, doing exactly what you just said. We're looking for alternative suppliers, and we're asking them, hey, would you have at least a pallet in the corner of your warehouse? And somehow we've been able to find it and keep going. But that's not the only thing, of course. Everybody's pretty well aware that we have shipping issues, that we don't have enough drivers. So, you find the materials, you make it, and all of a sudden there's nobody to pick it up. Well, then we come to the next thing, the big surprise. If that wasn't bad enough, February has a big Texas freeze. Now, that's not news to you, Matt. How cold did it get?
It was 5 degrees out for we were 150 hours below freezing, which is ridiculous for us in Austin.
Oh, that is ridiculous for sure. But here's what it does to us. So Texas, basically the South, houses a lot of oil refineries, and they're outdoors, they're big equipment. Well, they're not prepared for that. Why are they in Texas? Because of the nice weather. Yep. You can be outside. So we got pictures back from some of our suppliers. They take what comes out of the refineries, they refine it more, ends up in our products. And we saw this picture. We couldn't believe it. It's this outdoor plant, and there must have been 1 to 2 inches of ice coating every stinking piece of equipment. Oof. Tank, valves, pipes, control systems, all totally encased in ice. So what that meant for us was a significant supply disruption. So they put us on 50% allocation. That started back in February, right? Matt, that was early February.
Yeah, that sounds right. Yeah.
So we're still on allocation. We think we will be in May. We've been able to eke out a little bit more than 50%, but we feel like we might be lucky if we get what we actually want by June or July.
Oh my gosh,
what does
5 months.
In terms of, so you think of that empty shelf at Home Depot. Well, let's say we get supplied. We then fill our back orders.
Mm-hmm.
Well, then Home Depot brings it in. What's going to happen to that shelf? It's going to instantly disappear.
Yep.
So the whole supply chain is going to reorder. So we're looking at September, maybe, before we think we can actually get a smooth supply.
Sounds like the toilet paper debacle all over again, Les.
Yeah, that's right. Well, and then we have another one cropping up. So we're thinking, man, let's get out from under that. We can get enough of our polymers to make product. We've actually got some issues with cartridges. So the cartridge supplier, hey, it froze more places in Texas. They got a plant in Kentucky. So they've put us on 90% allocation. And you think, well, 90% is pretty good. That's compared to last year. Matt, you know what's happening to housing and the demand that's out there. So
crazy.
We're probably up 20% in demand. And if you get 10% less than you did last year, we could be on a 30% shortage of what people want just in cartridges.
Oh my gosh,
so,
what a mess.
Yeah, I think people will be scrambling to package it any way they can. I mean, don't be surprised if you go to the store and you find sealant in a brown paper bag. I mean, I don't know what we're going to be able to do, but we're going to keep after it.
What a mess, Les. It sounds like there's going to be situations soon where we're not going to find the products that we're used to using, including sealants. Here's what I would love for you guys to do, my two chemist friends. Walk me through some of the key sealant technologies out there. What are the performance trade-offs? Because what I'm thinking is if my audience understands the difference between category A, B, and C in a sealant, that allows me to be more knowledgeable to go, okay, my usual product that I use is not available. What about this other one? Will this work? Would you guys do that for us?
Absolutely, yeah. You've hit exactly on it. So there's several different technologies. And by the way, all of them are hit by this shortage of supply just in the oil stream and the chemical stream. So almost no matter which one you're talking about, you just talked about drywall mud. That's one of the similar streams that we're talking about. So there's two basic technology types. There's a reactive, and we're going to split it. We're going to try to really simplify this for everybody because we know we're on podcast, so there's no visuals there. But we're going to split the technologies into two types, and it happens to be around how they cure: a reactive and evaporative. So, as you're saying, when you know the difference and the characteristics, you can make successful swaps. So Nathan, help us out and tell us a little bit about the high level of what's the difference in these reactive and evaporative kind of technologies.
Sure thing. So reactive products all cure basically by reacting with atmospheric moisture. So when they cure, they're going to have a few predictable properties. First off, they're going to cure a little bit harder than evaporative products. Hardness can be a good thing, right? If you're thinking about resistance to abrasion, but it can also be a bad thing. If you think about, a joint that needs to move and flex, or a new house that's settling, sometimes those products are going to crack a little bit more than a evaporative product.
And you don't want your sealant to be resisting that movement, right? Because it pulls against the substrate. So you can either crack or tear something away.
Right.
Yeah.
Reactive products are also moisture sensitive, right? Since they're reacting with atmospheric moisture. So, one thing to keep in mind if you're switching to a reactive product is you can't reuse the cartridge. Once you've started using it, it's going to kick over and you're going to be left with a hard film. So if there's any product left in the tube, you're probably not going to be able to get that out.
Yeah.
There's also, when it's moisture sensitive, there's some characteristics you need to watch out for if you're going over damp surfaces or if you're in an area of really high humidity, right? It probably makes sense if you're putting a moisture sensitive product on a damp surface, you can get some funny things.
So what exactly do they do? I know that, Nathan, I was up in the Northwest at a trade show, and I ran across a contractor, and in the Northwest, very wet. So, and we're going to talk about the evaporative, which is a water cleanup. But I was interested, and I said, well, I don't quite get it because you're using a lot of water-based product here in the Northwest, very rainy. And he said, well, yeah, I switched. My switch was from urethane to Big Stretch, in this case, water cleanup. I said, okay, I don't get that because you moved from Spokane dry place to wet places. Well, I can't use urethane in the on wet surfaces. So explain why he would say that.
Sure. So when you put a urethane on a damp surface, it starts curing immediately right at the surface, right? And so in the situation you're talking about, we actually got some of the product back and we looked at it under a microscope and you could see bubbles and almost a foam at the surface where you're getting a lot of structural imperfections, right? And so that's actually ruining your adhesion to the surface.
So
it's taking over so fast.
It's forming a foam right there at the interface. Okay, so you can imagine you're not going to have much strength there, much adhesion.
Right.
So if we move to the evaporative, what are some of the characteristics there?
Sure. So evaporative products have either water or solvent as a carrier to help deliver them to the surface. So they're going to dry when that water or that solvent leaves the film through evaporation. So typically they're going to be a little slower drying than their reactive counterparts. They're also going to be a little easier to apply, right? You can think about the fact that they're going to be lower in solids than reactive products. And so when you're gunning them out, they should go on a little nicer. Sometimes they can tool a little bit nicer as well.
So Matt, we were talking earlier, and we're talking to these technology swaps. When we visited out there, we talked about, hey, you thought Big Stretch, so that's a high performance acrylic, it's water cleanup, was useful only for interior. I'm not sure we've convinced you otherwise. But maybe by the end of the show, you'll see it differently.
That's definitely a surprise to me that you could use it on exteriors. Long before I knew who Sashco was or had met you, Les, I had used Big Stretch for a long time and really liked it. I felt like it was that premium interior trim caulking, but honestly, I didn't understand that it could be used on an outside. Help me understand where each of these sealant technologies can be used and if they'll behave differently in those environments.
Yeah, well, I think we'll do that. We're going to get into specifics on the swaps. So right now we're just going to, and this again, we're going to simplify these things. So we talked about the reactive, the evaporative. Now let's get more specific into the technology. So we're going to talk about urethane and swapping out for high performance acrylics, or swapping either way. So if you're using a high performance acrylic, you could possibly go to urethane. If urethane isn't on the shelf, you could possibly go to the high performance acrylic. And by the way, we're talking about such things in urethanes like NP1, Loctite makes one. There's a lot of urethanes available. And then in the case of the high performance acrylics, a good example would be the Dynaflex 230 from DAP. Of course, our Big Stretch from Sashco. And so because you can swap those two, you can do so when you understand the characteristics a little bit better.
Can I interrupt for one quick question, Les?
Sure.
How do you know that NP1 is a urethane? You guys are chemists and you probably understand all those, but me as a builder, is there any telltale sign when you look at a tube to go, oh, that's a urethane, or no, that's a water-based or solvent-based evaporative cure?
Well, you know what? You make a really, really good point, Matt. Now, most of the urethanes actually say urethane or polyurethane on the label.
Okay, that's good.
But we are finding that in some cases, you will not find that on the label. For instance, in a high performance acrylic, it may not say it's acrylic or water-based. And later on, we're going to talk about hybrids. We don't want to confuse it right now, but sometimes on those, they don't say either.
Interesting.
So there's a little bit of a detective work to do on those things. But
that's part of why we're giving you a few of the most common brand examples, right?
Super helpful. This is super helpful.
You could look at an SDS to try to figure this stuff out, but hopefully our examples will key you in.
So can you get a little more specific, Nathan, on like the urethane versus a high performance water-based acrylic?
Absolutely. So, to start, both products are paintable, right? That's part of the reason why you'd use them. Yep. They're also both going to meet ASTM C920, which is a spec that talks about joint movement and having some longevity and some durability when flexing.
Right. So most urethanes will meet that.
Right.
Now, when you get into the acrylics, that's something you really got to look for to make sure you got high performance. But Matt, one of the things I want to bring out on that too is specifications, although they're great, they're just a starting place, right? We've seen items, fail where they shouldn't fail and work where they shouldn't work according to the specs. So just keep in mind for your audience, specifications are laboratory tests. They're not out in the field. Right. And so the contractor is really the last answer.
Right.
If this is working for you, keep using it, but it's a good way to start just to kind of initially qualify that higher level.
Sure. So if we dive into urethanes, right, that's our reactive product. Acrylic is evaporative. So like we mentioned, right, the urethane's going to dry harder. One thing specifically to look out for with urethanes is they're the most moisture sensitive of all the products. They have a chemical called in there that's a little bit of a nasty chemical called isocyanates. And that's a bit of a skin sensitizer. So you'd want to be careful, putting that on. And then it also has a bit of a smell. So urethanes are really, really good outside, or if you're doing a new home, right? But if you're doing a project where there's people in the house.
Current remodel or something,
Right, maybe not so much for urethanes.
And Nathan, you're also, because of that, probably not going to use your finger to strike that product down, right? Because you don't want to get it on you.
So we might not recommend it. I think a lot of people probably would anyhow because they're used to it. But certainly, someone who's not used to it, you'd want to be careful about that because it's a little nastier than an acrylic for sure.
Got it.
When it comes to biting your finger a little bit, you'll know it's there. That's for sure.
So urethanes will dry kind of hard, as you're saying. So they're unes that will, they're more likely to tear the substrate. So for a couple of reasons, we probably wouldn't put urethanes on the inside. Urethanes on the inside, you're going to have more fragile surfaces. So you're going to tear drywall. You're going to tear away from paint. If you get some significant movement.
Yeah, that's a really good point. So urethanes are so strong, so durable that when they fail, sometimes they can damage the surface that they're coming off on. So they might actually pull the concrete. And if you have to go repair them, you might need to patch the concrete or the drywall and reseal.
So now we'll ask the dangerous question. So Matt, you've probably used urethanes on the inside and been successful. So you're just going to totally destroy our story here.
Actually, I have not used a lot of urethanes inside. I've definitely used them outside. I used the NP1 on my house 15 years ago in between my brick and my garage jams, my brick and my windows. And it's held up fairly well. I did a really good job of backer rotting to make sure I didn't get adhesion on three sides. But interestingly enough, where my house faces west, I've seen a lot of degradation from UV damage on that urethane. Can you tell me about that? Are urethanes versus acrylics more UV sensitive?
They are. So traditionally, you'll see that those reactive products are going to be a little bit more UV sensitive than their evaporative counterparts, and that's true for all the swaps that we'll go into.
Okay.
Yeah, and the acrylics, the high performance acrylics. The best way to explain that is, they're great against UV, but why do you know that? Well, it's because the same kind of acrylics are used in exterior paints.
Ah, there you go.
So when you have that kind of confidence, you're getting a higher level product, they're great against UV.
Interesting.
Let's talk for a second about, what to look out for if you swap the other way to an acrylic from a urethane, right? This is your evaporative product, so it's going to dry a little bit slower.
Yeah.
The other thing to watch out for is shrinkage, right? These are lower solids products. So when it dries, it's going to have a little bit of a concave shape to it versus the urethane that's really going to, you know, the bead that you put on is the bead that you're left with. So it's not necessarily a structural issue, but it's something that can look a little bit off if you're not used to it.
So we're talking aesthetics versus performance. So performance is okay, but hey, literally, if you want a lower shrinkage, sometimes you may have to put 2 applications if you're using that.
That's right.
To get to the level you want. Well, this came up really pointedly last year. So here's the importance, and you started out saying this, Matt. Look, if you know some of these characteristics, you know when and how to swap. We had a complaint out of California. They said big stretch isn't curing. Well, we know if the water leaves, it's going to cure. So what in the world's going on? So the contractor noticed, the next day it wasn't firming up. So he got out his water bottle and started spraying it, and it kept not curing. And he sprayed it every day. And finally, it just failed. Well, he was treating it like a urethane. So he's trying to kick it over faster by spraying some water on it, not knowing he was dealing with the acrylic technology.
That's funny.
So that would have saved him and everybody else in the job a lot of problems.
That's hilarious. 2 questions, if you don't mind me interrupting. This brought up while you're thinking about spraying things. Les, last time we met, you gave me a tip that I'd never heard before, which is if you're striking down an acrylic, you could use clear Windex to kind of pre-spray that acrylic, and then it would not drag on your finger, let's say, as easily. What's going on with that? Is that across the board with all acrylics?
It is across the board with all acrylics. And in fact, we're going to get into some technologies here in a second that it works on as well, surprisingly. But what's going on is that has enough soap in it to give you a very slick surface, so that instead of dragging your finger through and ending up with more caulking on your finger than in the joint, you can actually glide over the top, just smooth it out. So the whole job of tooling is just smoothing it out, making it look aesthetically good, making sure you're in contact with the surface. But that allows you not to grab all the material out and then it's on your finger and it should have been in the window.
Yep.
So it's a really good trick. And the nice part about it is, I mean, it's readily available. Buy clear window cleaner, but don't use blue or the colors, because yes, your caulking will end up blue.
Right.
Makes sense.
So that's a problem. So let's move on. So now we've got the urethane and the high performance acrylic. So you can swap back and forth. Now let's look at 2 other technologies. One is going to be silicones on the reactive side and copolymer rubber on the evaporative side. So examples, everybody knows silicone pretty well. GE puts out some silicone. There's a lot of silicones. Just some examples, though, to your point, Matt, what's in that cartridge? GE 2300 would be an example of a copolymer rubber, as well as our Lexel product. So, Matt, again, take us down the road on these 2 technologies and how does that swap happen?
Sure. So first off, the reason you'd use these 2 as opposed to any others is probably moisture resistance. These are going to beat out anything else in terms of resisting water, which is good. The silicone is our reactive product, and the copolymer rubber is the evaporative one. So the silicone's drying a little bit harder, a little bit more susceptible to tearing. The main thing to watch out for if you're switching from a copolymer to a silicone is you can't put anything on top of a silicone. It's resistant to moisture, but it's resistible to everything else too. So you can't paint it.
So Matt, have you run into that? Is that common knowledge? Do you think that you're not going to paint a silicone?
I would say among builders of my vintage, yes, meaning old guys, but I think there's a generation of younger folks that don't know that necessarily.
Yeah, that's a good piece of information, isn't it? Because, and something I learned early on too, I didn't understand, is their silicones actually have a plasticizer in them. And if you put them on a porous surface, that will leach into the surface. And so the surrounding surface becomes not paintable. Mm-hmm. So when you wonder, well, why is my paint failing close to the silicone bead, even though the silicone might not take the paint, mm-hmm. it's because it's left behind that plasticizer.
I'm sure. So hopefully you don't get a failure with a silicone. But again, if you do get a failure with a silicone, you can't fix it with a silicone either, because silicone does not adhere to silicone. Yep. So, things to watch out for.
Smart.
If you're swapping the other way and using a copolymer rubber, there the main thing you need to watch out for is the stickiness, right? The copolymers have some solvent in them, which helps them wick into the surface. It kind of wets out the surface so you can get some better adhesion on things like plastic or wood, but you can also get it on your hands, right? And if you get it on your hands, it can be sticky. It's tough to get off, just like it is from the joint. So that there again, Matt used that trick, a little bit of some window cleaner or a little bit of soap. Yeah.
So the surprise too, to me on that, when we started experimenting was, window cleaners, water-based, but you can actually tool it over a solvent-based system, which is really convenient. So if you got a bottle of clear window cleaner, you're good to go on most items to smooth it out.
Right. The last thing you probably want to look out for switching to a copolymer is there is a lot of solvent in there, right? So toluene or xylene, maybe a little bit of naphtha. So it's flammable. You don't want to leave a ton of it in a truck in a super hot day. And it comes with a little bit of an odor there too. If you're using it inside, especially if you're using a lot of it, you want to make sure that. Right. It's different than a silicone odor, which might smell kind of vinegary or maybe like some menthol.
Yeah. So, and they tend to be a little clearer than the clear silicones. The clear silicones are more like a translucent. So if you're going up against glass or a countertop granite, when you want something to really disappear, the copolymer rubbers are a really better choice. So any comments or questions on that, Matt? So that's a technology swap between silicones and the copolymer rubbers.
That's really, really good information, guys. Really good information.
Good.
So there's a more recent technology called hybrids. And so hybrids are exactly that. They're kind of a hybrid between a silicone and a urethane. So they are a reactive as well. So like Quad Max from OSI is an example. But here again, Matt, to your point, reading that label, you wouldn't really know that. So take us down the trail of the characteristics then of the hybrid, and then what can we swap with that?
Sure. So with a hybrid, it's traditionally going to be the same swap to a copolymer rubber or vice versa.
Can we go to a high performance acrylic swap?
You could. I'd probably default to the copolymer, especially if you're doing an exterior project. But there are probably examples of where you could. Part of the advantage of a hybrid and a copolymer is that they're truly use anywhere type of products. You could think of them as the all-purpose. I'm not quite sure what to use, so I'm going to pull this out, and it's probably going to do a pretty good job for you, because it brings in the advantage of that urethane that it's paintable, but it has some of that moisture resistance of the silicone.
Now, the other thing we found, I think, is that Nathan mentioned that silicones have a fairly low tear resistance. So you get a little tear in it and they'll zipper along. The hybrids tend to do that too. They kind of inherit some of the weakness of the silicones in that regard, right?
That's right. They're a little tougher. A copolymer can flex and bend. And the special thing about the copolymer is that when it flexes, it can stretch 300%, 400%. And when it stretches, it's actually in a low stress environment, right? So it's not pulling on the substrate. Whereas any of the reactive products, if the joint is forced to stretch that much, it's really going to pull and it's going to be stretched. It's not going to relax. And so that can be tougher, and then you can get tears and cracks ultimately from that.
Now, the other thing on these, the hybrids, they do suffer a little bit from the UV, right? UV will attack it. And so here again, either the copolymer or the high performance acrylics that really withstand the UV would be a good choice.
Yeah, if you're going to paint it, you're probably good either way. But if you want that real clear appearance, you probably want to stray towards the copolymer side, because the hybrids can pick up some of that yellowing when outside exposed to the sun.
So that's pretty much the technology swaps. Trying to make it as easy as possible, because I know the audience is listening. So, but
can I mention a summary?
Yeah, sure.
Real quick. So Matt, you talked about how do we tell what's what, right? And so one that you want to be careful about is what's a latex, painter's caulk versus what's a high performance acrylic. And one way you can typically tell is by looking at the solids level. So a painter's caulk that, you want a real thick, fast dry, it's going to kick over and you can go over top of it with your interior wall paint, is probably going to be 85% or higher in percent solids. Whereas a high performance acrylic is going to be maybe 70 or a little lower. So that's one way. You want to make sure that you're not swapping from one of these, more durable products like a urethane or a hybrid to a interior painter's caulk. Right. That wouldn't be something that you'd want to do.
Right. And they'd be drying a lot more brittle. So it's probably, Matt, why you went so many years thinking, big stretch is just interior, because you kind of related it to the other water cleanups.
Yep.
So we're trying to make that evident here. So you really have a little bit more flexibility in the technology you choose if you just kind of know some of the fundamentals. So here again, urethanes and high performance acrylics can swap back and forth. Silicones and copolymer rubbers, you can swap back and forth. And then with the new hybrids, you could swap to either a high performance acrylic or your copolymer rubber, just depending on the characteristics you're looking for. So we hope that gives you, some flexibility in the market when we're looking at empty shelves.
Guys, great information, but I know it's a lot to absorb for maybe the non-chemists in the audience. I understand you guys have summarized this into a document, though, for people who might be interested in a reference. Appreciate you guys doing that. We'll put a link down below for everyone to access that.
Yeah, definitely. We'll have a tech bulletin on this, and we'll have a few graphs and charts to make it a little bit easier.
Awesome. Guys, I really appreciate this. My hope is that these supply chain issues, and in particular sealant issues, maybe that we're going to experience, if you haven't already seen them, will abate by this summer or this fall. But Les, Nathan, really appreciate you guys schooling us on the chemistry and understanding how we could swap back and forth. Also appreciate you guys calling out a couple other products besides your own and talking about those and how we can use them and where we could use them. But
okay, well, we appreciate you tuning in for this special edition of Les's Corner. Stay tuned, because we talk about things like how to operate a family business all the way to this kind of technology talk. So keep looking for us. Thanks.